Hello, 516 students. This is the example, uh, online EX05 example. We're going to walk through this. We're going to do this for the independent sample t-test. There's 5 problems. So the first one says conduct an independent sample t-test with the dependent variable as the independent variable and the and the dependent variable and the independent variable as a independent variable. Is there a difference, non-directional, in the two population means? Write up results in APA, include the main SPSS table, use type 1 error 8.05. So notice that it just asks, is there a difference? Not saying that group 1's larger than group 2, for example. So we're going to go ahead and look for a difference. Okay, so we'll go to SPSS. Here's we're working with the 1 variable. And we'll open this problem up. Note it's the example data. So here's our data for the first one. Here's the dependent variable 1, and here's the independent variable 1. So notice that it's 2 groups. These are 2 independent groups. So we'll go ahead and do a t-test. So we're going to go analyze, compare means, independent samples t-test. Okay, we're going to pump over the dependent variable, test variable, and the independent variable for the grouping variable. Notice we got to define the groups, so we'll click down here, and the groups are 1 and 2. And we can see that right over here, 1 and 2. So we'll say continue, and then we're ready to run this test. It'll say paste. Now that went to my Sentex window. If your Sentex window is not already open, it'll open automatically. And so we can see it's pasted right here in my Sentex window. And I'm going to go ahead and block that and run that analysis. Okay, so here's the main table. Here are the main differences. So here's the main table we're interested in for the APA. So I'm going to say copy special, and I'm going to copy this as a meta file, and I'm going to bring that over to my Word document. I'm going to paste it right in my assignment. So from the assignment here, we'll go ahead, equal variance assumed, and so we're working on this first line right here, and we see it's a T. Its degrees of freedom are 18, and the sig two-tailed, because it's not a directional test, that's our p-value, and we're going to evaluate that as greater than or less than 0.05. So we notice that, so the APA is, it's a T with 18 degrees of freedom. Its value is right here, minus 0. Minus 0.350, comma, P is greater than 0.05. Again, in APA, if a number can't be larger than 1, it doesn't get a 0 in front. So here we notice that there's no 0 in front of the 0.05. But there is here in the value of the t, because that can be larger than 1. So this is not, we fail to reject the null, and we have no evidence that there's a difference in the population means between these two samples. And that takes care of number 1. Go to number 2. So it says conduct a dependent variable views t-test. We want to know if the population mean for group 1 is larger than group 2. So here we're going to do a directional test. So come over to SPSS. So we're working with DV2 and IV2. So we're going to go analyze, compare means, independent samples t-test. Click on that. So we're going to reset this. Then we're going to bring in the second variable, independent variables going in the grouping variable. We'll define these groups as 1 and 2. Continue. And even though it's directional, I'm going to do the same thing. I'm just going to go ahead and paste it in. So I'll go to my Centex window. Down here, I'll click on the SPSS icon. It shows me my three windows for SPSS. And here's my code that I'll go ahead and run. Now, going back to the assignment, we see that the question one is the population mean for group 2 larger than group 1. So when we do a directional test, it's a two-step process. So we'll go ahead and grab the table that we just got. We'll copy that over, paste it into my assignment, and so I'm also gonna paste in the means table for this one because I need to know that. So I'm gonna copy that. Because as I see my assignment, is the population mean for group 1 larger than group 2? Okay, so it's a two-step process when it's directional. First, did it go in the right direction? Is group 1 larger than group 2? Well, it is. So there we're going to continue, and we're going to look at our sig two-tailed down here. And because it's directional, when it's sig two-tailed, it's using the probabilities from both sides of the distribution. We're doing a one-tailed test, so we need to divide that by 2. So when we divide this by 2, it's 0.23, say 3. So it's still greater than 0.05. So when I write my APA now, so APA, it's a T with, we still have 18 degrees of freedom. Here, I'm going to bump this down farther so we can all see it on the same page. Okay, still has 18 degrees of freedom right here. Working on that top line, 18 equals, what's the value equal to? 0.709 right here, 0.709, comma, and P greater than 0.05. Well, the actual P, it's P's equal to, and what was it over here is 0.467, and I get that from right down here, divided by 2. Okay, because it went in the right direction, but it didn't, it's still not less than 0.05. That's equal to 0.2335. So we see the P is still greater than 0.05. So that's not statistically significant. Okay, we'll go on to the next one. It says, is the population mean for group 2 larger than group 1? Meaning it's still a directional test. Go back to SPSS. Okay, so I'll go Analyze, Compare Means, Independent Sample t-test. I'll reset it because now we're working with number 3 data, independent variable. Define my groups, 1 and 2. As I continue, okay, I'll go ahead and run the test, say OK. So I'll bring in both these means, so I'm going to copy this. Working on number 3. And I'll go get the other tables. So I want you to bring in those tables as well so that evidence is right there when you're running your analysis or interpreting these tables. Okay, so again, our research question was, is the population mean for group 2 larger than group 1? So we come to group 2, and it is not larger. We see that group 2, the mean is 4.79, but group 1 is 4.94. So is the population mean of group 2 larger than group 1? Well, by default, we're going to stop here because, again, it's a two-part process. Did it go in the right direction? And if it did, then you divide your sig2 tail by 2, but here it didn't even go in the right direction. So if I was going to write this up in a paper, let's say APA, and it's a T with, again, 18 degrees of freedom. We get this from our table right down here. It's equal to, what's my T equal to? 0.107, comma, and then P greater than 0.05, greater than 0.05. And that's it. We failed to reject. Okay, we'll go on to number 4. It says conduct an independent samples t-test as the dependent variable as as D4 as a dependent variable and IV4 as the independent variable. Is there a difference non-directional in the two populations? So here we're just doing, again, a non-directional test. So I'm going to come down here. I'm going to go to my data. I'm going to work with number 4 data now. Now notice it doesn't matter if I start with the code or the output window. It doesn't matter which window I start with. They'll all get to the same place. So I'm going to come up here, compare means, independent samples t-test. I'm going to reset this. I'm going to bring over my 4 dependent variable and independent variable. Again, I'm going to define groups. There's 1, and there's 2. Say continue, and then OK. So here's my table. So now I'm doing a non-directional test. We see that the group 2 is actually larger than group 1, but since it's non-directional, we're asking the difference question. So I'll go ahead and bring in this table. I'm not going to bring the mains table. In interpretation, I'd go ahead and bring that table in, but just for this assignment, it's not necessary. So I'll go ahead. It's a 2-sample test. So I'm going to write my APA statement. APA. It's a T, same amount, 18 degrees of freedom. Its values, what's the value of the T right here? It's minus 0.290, 0.290, 0.290, comma, P what? So is it less than or greater than 0.05? We see, oh no, it's greater than, not having very good luck here, 0.05. So we see that we're not statistically significant here. That means the difference we're observing is we think just due to chance. There's no evidence to suggest that they're actually different in the populations. Okay, so we'll go ahead and do the last one. It's a non-directional well, but you notice here our type 1 error rate is 0.01 for this individual comparison. So I'll come back to my SPSS. Now, one thing I'm going to do in this case is I failed to paste the other ones. I just said OK, so they're not in my syntax here. But you notice here, so I'm going to do number 5. Let's look at the data. So I'm going to do DV5. Now I can go through the GUI and click Analyze, Transform. But notice one thing as you start working with SPSS quite a bit, you'll want to use the syntax. So I'm just going to copy this syntax over here, up here, down. And if you notice here that I just have to, this is 2, and I want to work with data set 5, so I'm going to change this to a 5. You can do it the way we've been doing it, but the data is set up the same way. So by just changing these 2 numbers from 2 to 5, I can, now this is set up for the test I want to do. Okay, so I'll go ahead and block that and run that. Okay, now I did something wrong, so I'm going to go back and look at what I did. Okay, that I failed to write the 5. So I had a deleted spot there. So there I go. Okay, so it's 5 and 5. So I was just missing the 5 on this. So I'm going to go ahead and run that. So here's my table. I notice the means are different in the sample, but again, my question is in the population. Okay, so I'll go ahead and copy this into my document. Oops, undo that and go back and copy, make sure I'm copying the meta file over. Okay, so there's my meta file. And so it's a T. I'm going to do my APA. It's a T with, again, 18 degrees of freedom. That's coming from right here. Equals 0.547, comma, and what's my two-tailed P, right? So it's 0.594, which is greater than 0.001. So I failed to reject. Okay, so this is what you got to do in the actual assignment. Go ahead and run yours. Yours might be greater than or less than. Okay, so there's what you have to do in the assignment. So thank you so much.